Welcome back. Thank you, John, Bob, and Cone for joining us. We're going to get a little bit more technical. Again, this is more on the kind of data strategies, thinking of OSS, BSS for AI success. And when we kind of set up this panel, we talked about really getting into things like how does legacy APIs and modern data connections and streaming technologies or techniques get to be used better for AI. And I'll start with John. Let's pick up kind of where we left off on the last panel when we were talking both about opportunities and some of those boulders that we talked about. So can you describe a little bit some of the legacy data issues that we're all maybe suffering from in OSS BSS systems that constrain a telco's AI effectiveness as of today?
Right.
Please.
So legacy and telco, this is nothing new, right? It's an issue that as an industry we have been grappling with for decades now. And if you actually trace it back, there has not been a single reason why we are where we are today. There's been a multitude of different decisions made under different context. But one of the leading factors was that, especially if you go back 2 or 3 decades, a lot of the systemic transformation that happened within telco was highly compartmentalized, usually led by teams or departments. And the preferred approach at that time was the best of breed, where, you would get a solution for whatever it stood for, and then you would manage the integrations later. And over a period of time, that led to silos, multiple silos, as, you have sometimes, and many of those older systems were never retired. So the scope reduced, but you would bring in new systems to take on additional responsibilities, manage scale, maybe support new use cases, and so on. Then there was the issue of M&As, which also brought in, say, 2 sets of these systems. And oftentimes the operator would find a way to navigate with all those systems rather than finding a way to scale it down. And what that has led to is that the spend on legacy support and maintenance has surged. According to our estimates, just in the billing domain, of the total spend in a year, roughly 2/3 of that money just goes into supporting legacy systems. That's a lot of money, right?
Yep.
And that too into systems that don't have a future, right? They are just there because they not supporting that would disrupt ongoing operations. So and I'm sure all of us have heard stories like this. There's this tier one operator in the US who at one point had over 300 billing systems. Right? Can you imagine the silos that would come out of that? There was another operator in Nordics, who was in the middle of a transformation, and in smaller operator, they had about 12 or 13 billing systems, and they wanted to consolidate that into one. And midway into that transformation, they called it off because they realized that the cost of gains or the actual value they expect out of this was less than the cost of not meeting certain SLAs, because there would be a risk of disruption to operations, right? So where we are at now, especially pre-AI, was that we got to a state as an industry to learn to live with it, right? We would manage it somehow, maybe bring in an adjunct system, and so on. And what AI has changed for us as an industry particularly is that we recognize the access to data is vital, right? Context is the killjoy for any agentic or generative AI applications. Unless you have the context, you just cannot scale it beyond a particular team or department. And that's where we are getting into these conversations around, now we have a problem that we need to resolve rather than work around. So I believe AI, probably more than anything else, has brought to the fore why legacy needs to be addressed ASAP.
So obviously one of the tools available is this kind of event-driven architecture.
Right.
So spend a minute on, I think most people know it is when we give the introduction, how it plays with APIs and other
Right.
kind of tools available. And then talk a little bit about, we talk about this fuel for AI, right?
Right.
Data is the fuel, but we have to do something with it
Right.
to get access to it. So spend a minute on EDA and how it is this fuel,
Right.
if you don't mind, please.
Right. So EDA, event-driven architecture, it's as a concept, it's still new to telco, but it's not a new thing per se. If you look at some of the larger big tech companies like Netflix and others, they have been using this for a long time. the idea is that, so the legacy framework, I don't know if, okay, the slide is up. So what you see on the left side is the traditional way where multiple systems would be brought together. For the sake of simplicity, I just picked up 5 different systems, and so you can imagine interconnection points. But just think of that tier one telco that I mentioned about earlier. 350 or 300 plus billing systems. Can you imagine the number of interface points and the cost of supporting that? Right, that doesn't scale. So the idea of point-to-point integrations, that era is over, right? Especially if you have to get ready for AI. And what event-driven architecture offers you is that it is an event broker, where it's like an old pub sub model, where anytime an event happens, the entity where that event is registered publishes the information. This is a simplified view. I'm sure the technical minded of you has a far better understanding of it. But it publishes that detail, and whoever is on the receiving side just needs to subscribe to that and gets access to that. Now, how it helps is that you don't need to worry about point-to-point integrations anymore, which is where a lot of the money and time and effort is spent. So why hasn't it taken off in telco as much? I think it goes back to 2 reasons. Because in the early days of EDA, one of the concerns that was called out is that it is a bit like fire and forget, right? That it doesn't handle the context, it doesn't hold the state. And I think that is dealt with today, right? EDA allows you, there are different tools that allows you to observe how data flows, who publishes, who subscribes, what is the state of the information, which means you still have observability. That's quite high for telco, right? They need to know and track how these events are being mapped. So I think EDA is ready for prime time in telco today, and it probably is one of the biggest drivers that can enable how especially legacy migration can be accelerated.
So Bob, in your role in a leadership role at Wavelo, you're actually taking some of that perspective on EDA and bringing it to the TM Forum, and specifically the TMF Async API working group. Can you talk a little bit about how Wavelo is working with them and kind of maybe bringing some of those shortcuts to make the connection with,
Sure.
please?
Yeah, so the async working group was actually established, I believe, like 4 years ago, and it kind of faded out a bit, and now we've kind of revived it based upon our success at Wavelo, leveraging the EDA and also the different industries using it. I think 2 of our goals are trying to figure out how to leverage the embedded base of all the APIs that have been defined and vetted. I mean, there's 100 different APIs that talk up to all the actions around business entities, but there's thousands of customers and vendors that use these APIs. So we want to figure out a way to leverage that information. Um, but the other goal we need to have is coexistence, because there's no bridge that immediately everyone will go from a synchronous flow into more of an async flow. I threw out one slide that we had in our working group, and yes, correct. If you look at the REST API flow on the left, it's straightforward, where a client makes a request, the server receives it, it processes on it, and sends back a response. On the async side, it's very similar, but now you have the event broker in the middle, the EDA managing, where I now publish a request. The server is waiting to consume the request. It processes on, sends it back. So in our group, a lot of folks are still tied to that REST API because they don't see what the value is moving to the async. But I think we're making strides in the value is the one-to-many communication. When that client and server are interacting in the async side, it is a one-to-many. It's creating a stream of data that anything can consume on. And so what's changed in the last 3 or 4 years is now this need to share information with AI. On the right-hand side, with all those point-to-point interfaces that John had in that mesh, it's very difficult to pull data out, and it doesn't have any kind of context. Even if you grab data from multiple systems and put them into a large data lake, it's still kind of static. And what we're trying to do is grab this information and leverage the flow of the EDA, leveraging those streams of information that are real time, but also they capture telemetry. On our flow on the async side, we can capture how many times this went through. It's historical. I can stream data immediately, but I can also look back in time because it's retained. and it's also scalable. The other thing that's coming around is that large carriers that now have hundreds of millions of subscribers, the REST API does not scale. They can't get enough volume through, and they're looking to go to ETA just for the scalability. So that's kind of the stuff we're doing inside of our working group.
So, Cohen, you're a former telco leader from a technical perspective. You've been an advisor in the market. You've participated in these kinds of projects. This is actually from a catalyst, I believe, that you worked
Yep.
on with TMF, where you picked up on some of what Bob was talking about. You made that connection between REST-based, R-E-S-T, the kind of point-to-point based components to new EDA frameworks. Can you talk us through a little of this and what the benefit to the
Yeah.
service providers?
Yeah, so actually there's been at TM Forum, there's been two catalysts around Async APIs. Async APIs is basically that sort of event-driven APIs that you're going to use. And the first time, the first exercise was a bit of saying, okay, we've got these REST APIs, and we need to see if we can actually use an asynchronous protocol to send similar messages, right? And as a result of that, we implemented a very particular pattern, which is called request reply, because if you have a REST API, you expect either a response that says okay, or a response that says it's not okay, something went wrong. So request reply brings that same sort of pattern, right? So you get confirmation that something happened. In fact, we found out that that is not very event-driven. It uses event infrastructure, but it's not event-driven. So that's why we had the second catalyst and said, okay, let's expand this scope and say, okay, let's try and make it more event-driven. But at the same time, look at this huge telco problem of all these legacy applications. And yes, we have these REST APIs, and they've been around for more than 10 years, maybe 15 years. They've been implemented at most telcos by now. There is thousands, even millions of downloads of these specifications. So that means a lot of people are actually using those at different telcos all over the world. How can we build something that is sort of transitional, brownfield, right? Because no telco is a greenfield, right? They're very rare, right? The most actually have these lots of legacy applications. And how do you connect these legacy applications to new event-driven applications? Because you're going to have to live with both worlds for a long time. And that was basically what the exercise was. And there was a bit of a paper exercise in parallel where we're actually saying, okay, and what needs to happen to make that a robust infrastructure? So that is basically what the exercise of the catalyst was. And as Bob was saying, then it went a bit down because for the telco industry, the use case was not urgent enough to actually say, let's go with this, right? But that changed recently because now there's suddenly a lot of interest from the telcos again saying, hey, but isn't it a solution for this other problem that we have? We're getting AI questions, and it's about getting access to our data. So if we can translate our existing APIs in a model that says, yes, I can still do a REST call, and then make it into something event-driven. And on the other side, I do it from the event-driven back into a REST API. I can use my existing integrations, but actually sideline my data objects and actually get access to my real data. And that is one of the huge problems that telcos have. All this data is currently sitting in all these silo applications, hundreds of them, as has been told already. So now we're actually finding a way where the telco can actually get ownership of its data again and actually make it ready to be used for AI-driven agentic applications.
So these are kind of new relationships and different kinds of data calls, as you mentioned.
Yep.
I'm going to ask John to step back a little and talk a little bit about, let's call it this data relationship framework. A word we've heard a lot this week, if you've been in any data-centric session, is ontology, right? And taking a little bit from science, from the double helix, from DNA, and now talking more about how we make that connection. We organize and manage some of those data calls that Cone mentioned. Can you take a second to define ontology in this context, and where do you see its role between the data and actually delivering on some of these agentic AI activities?
Sure, sure. So I think one of the most distinct changes in the narrative that we have seen at MWC this year compared to the previous years has been that there is a far greater emphasis on the underpinnings of AI. In the initial years, since generative AI burst on the scene, we have been quite excitable about what AI can do for us, first generative, then agentic. But I think we are now having a check-in with reality, and that is that as an industry, we need to take care of the underpinnings before we can actually realize value from AI. We at Apple, we have a very simplified three-tiered pyramid view of how this looks, and that is with data layer at the bottom, the ontology or the semantics in the middle, and the AI applications at the top. Now, a lot of the demos and niche use cases that we have seen have been impressive because, by and large, they were highly compartmentalized. So context was never an issue. It had access to the relevant information to make the right choices, and the outcome seemed impressive for what we are used to. The challenge was when we scale it across, especially large telcos, multi-vendor environments were mired in legacy. This would go out for a toss because the data wasn't there, context was not always complete, and that is where I believe more and more, back to your point about ontology being a big topic here. So that bottom of that pyramid is data, and I think we already spoke about how that migration challenge needs to be addressed, the silos need to be brought down, and that has to be done in a timely way. If you are starting on a long-term 5-year project to bring data into a consolidated data lake today, AI way would have passed you by the time you're done, right? So it has to be done in a way where just like EDA does, bringing it as a layer on top without actually having to spend years transforming it. Ontology, essentially, it's like the semantic backbone. And why it is especially important for telco, is that telcos have a unique language. We have way more acronyms than any other industry, some of which we don't even know about, right? And we also have a lot more systems than that is mired in silos, So we, as an industry, we don't have a consensus on what ontology means. But I usually, and there are different definitions flowing around. I would, just as a check, would refer back to one that is put out by Palantir. The Palantir ontology model breaks it down to 3 components that makes up ontology. The first being the semantic, which is basically knowing what a customer is. It might be called as a customer, account, MSISD, or whatever that character is. It might have different names across different systems. That's semantics. The second step is what is called kinetic, which is basically you have that mapped. Now, how do you make a decision? So there is insight, or what is called the decision data. How is a decision made on what is the right path here? And the third is what they call dynamic, which is what is the action to be done. So ontology usually comes together, at least as per that definition, as these 3 bits coming together. And I believe it's only as effective as the data underneath it. And that's why, we had that chat about EDA earlier.
So Bob, I'm going to ask you to kind of make this real for us.
Sure.
We talk about this framework and what it can do for us, but it can drive a level of truth for the customer. So I'll put up Wavelo's approach here, and I just ask you, how's this data framework work in active projects? What was it like in the field?
Yeah, sure. So what we're trying to do is not define a flat ontology that's static, but more contextual, that John hit on, where it's dynamic. So we are modeling the business entities, but we want to model the activities around those entities.
Mhm.
We want to see the actions and the interactions between all the systems that are in that telco space. And we can start providing as the events as our unit of truth that we're tracking. So inside of these are not building blocks of data, but they are actually topics. They're streams of information related to a different business entity. And so this provides that real-time view that AI wants to see, but also this is all semantically integrated, leveraging the best of breed efforts with TMF and the different business entity structures they've defined. So we have the same payloads that from the REST side, but now we're representing those into our event-driven architecture. So the data in and the data out is well defined. So AI knows what data they can see and what's going to be what they can consume. But also we have a schema validation coming in. So we make sure the data going in is validated because we are interfacing to a lot of other systems that may or may not be TMF compliant,
Mhm.
nor even event driven. So as a client hit it, and we want to be able to translate those from REST into the event driven architecture. But why are we doing this? This is all for AI,
Yeah.
right? We all are building this structure that it's well defined because AI, what it needs is data that has no conflicts. So we want to make sure the data is real time driven, but it also provides a context where whatever stream it's listening to, because you want to be able to blend these together, they all semantically hold together and it can make sense and produce those insights we want it to find.
So one in the first panel we somewhat tongue in cheek said is OSS BSS dead because of some of this entanglement and this inability in past iterations of getting good data out. Kona, I'll put this question on you and talk a little bit about this. How is the architecture, the approach to BSS OSS going to evolve over time? And how is it, instead of being dead, going to actually deliver more benefit to the customer?
Yeah. Um, I think what's important is if we actually introduce this event infrastructure, then you're actually going to get to a situation that all your applications, even if they're legacy applications, interface with this event bus and communicate all the changes of state that happen with any type of entity that is handled by these applications. And so that actually means your event bus becomes your storage of data. It becomes your reference, your source of truth for everything that's happening within the organization. So if you look at the business entities that TM Forum defined, there's about 100 of them. Um, that actually defines most of the telco industry business models that are needed. And so you have a common model that is understandable, that is actually having a common ontology. Even if you have different applications, they're just plugging into that model and actually providing you the compute part of the information. And then you can plug into the same bus, you can plug in your AI agents that actually will do some of the interactions that are required and do your optimizations that you want to do. So you actually get a system that the event bus, the source of truth, your legacy application still working with that same data, and the AI agents actually getting access to that same data as well. And so I think that's where the telco industry, the OSS BSS needs to grow to. And it's something that can happen fast if you use that sort of integration technologies that we tested in the catalyst. So it's really something that could go fairly fast within the telco environments.
So I'll kind of last question. I'll start with you, Cone. Are you bullish that the way in which the telcos are set up today, as a former IT systems manager in the telco, that they'll be able to adopt relatively quickly this architecture based on where their investments today, their understanding of where TMF is going from a API perspective, the value of EDA? Are you bullish that this will scale the way you hope it can?
I think I'm fairly bullish that it will scale that way, and it's not that difficult to get it implemented. So it's not a change what requires a lot of change on the existing business side. So it's not like you have to train people to do different things, or it works very well under the hood in an existing OSS BSS.
Share the bullishness, John?
I do. Remember, this is not a new concept.
Right.
We have already seen Netflix and other large-scale big tech try this out. So I think we are at a tail end of this adoption cycle, and it's a mature technology. I think one of the biggest, and I mentioned it earlier, concerns at that time was that maybe the determinism, right, in a pub-sub model, this even broker make telco lose track of observability. And I think all those concerns have been addressed now so that it's actually a career-grade solution today. So this could actually go faster than we think, once telcos get into that string.
I'm assuming you're bullish. I hope you're bullish. And you've already seen it in action, right?
Seen it in action. Everything we build at Wavelo is based upon this framework I talked about, but there's a lot of things that it does that we didn't talk about. I mean, talk about transformations. Everything we do at Wavelo enables transformations.
Right.
I think Justin hit on a migration we did from a legacy billing system in less than 6 months. How can we do that? Because we have streams of information rather than these big bulk moves of data. We don't have to shut anything down to move the information in an incremental way. And the way you can start hydrating any system that you're ready to move in is so simple. I think we're even going to enable transformations. So definitely bullish.
That's great.
Yes, and I think
Good.
I'd like to jump into that. One of the things that I've actually seen in action is that you can say, okay, I don't know, I've got 5 CRMs that I need to integrate. You can basically have them running in parallel, actually all publishing their data in the event bus. And then you can say, okay, I want to see the data from this CRM in this CRM. And you'd actually just see it because the data is all there.
Yep.
It's all there. And you can trial run that for as long as you need for all your tests to go through. And then you can switch off one of the old systems, and you actually have integrated those systems based on the same data model, based on the same event bus, and it makes it very flexible to actually consolidate some of these legacy applications as well.
I appreciate the excitement. We don't get that excited about OSS and VSS systems. So I'm going to thank our panelists for coming up, getting into some real examples around EDA and the architecture. And I'll let Paul introduce the break real quick, but thanks for coming up.
Thank you.